So I purposely gave this with the F and G's kind of switched in terms of how your mind uses them. So I didn't give you any F functions up there, but I told you that they're inverses of each other. So you should be able to write the rule. If I want to find f prime of -1, but I only gave you the g function up there, okay, and they're inverses, inverses automatically mean we're doing a 1 over, right? Who's f's inverse function? It's g, and I'm going to take the derivative not at -1, where I'm actually taking the derivative. Where am I taking the derivative? At 5. How do you know that? Because if this is f's x value, listen, if it's f's x value, then on the inverse function, it'll be the y value. I purposely did it where the f and g were kind of flipped around so that you understand the relationship as it goes back and forth. I just blue ties mine. Are you okay? Are you good? If they're inverses of each other and -1 is f's x value, because it's inside here, does it make sense that -1 must be g's y value? Because they switch, right? So if this is g's y value, then I need the x value to help me find its derivative. Travis, we're good? Getting there. The switching, it's confusing. I get it. No, up here I'm saying f of x is g's inverse. And that's the same thing as saying g of x is f's inverse. They work back and forth. They're inverses of each other. So here on g, g's point, oh actually let me do it with the second point. G of 5 equals -1. Therefore, f of -1 equals 5. Yes. If I inversed it twice, yes, you're kind of undoing the work, but I'm not. I'm telling you that f's inverse is g, and g's inverse is f. Inverse, the definition of it means that it goes both ways. So if you find f's inverse g, then g's inverse is also f. They go back and forth. I see what you're doing. You're trying to take an inverse of it, like you're substituting, right? You're taking an inverse of an inverse? Okay. I see what you're doing. I understand it. Therefore, the answer becomes 1 over g prime of 5, which is 1 over 5. You can't get away with not knowing the rule for this type of question. There's no possible way because you can't try and solve for the inverse. All the other questions, if they give you the function, you actually can try and solve for the inverse. It works. And then take its derivative and substitute in the x value. But this one you can't. All right? This is the key, understanding the switch. They're inverses of each other. Understanding this, being able to write the rule every single time, that makes it easier. If you can always write the rule, I think that's a good place to start. Okay? All right, so I am going to go through, maybe not a proof, I'm going to talk about some major things about inverse functions that you need to know. This is quick, and when I say quick, I mean fast. Review, okay, because I need you to understand that they are different than the regular trig functions. So, understanding quadrants and domain, let's talk about y equals sine of x. I'm going to write these notes a little different. Y equals tangent of x. And I'm going to find the domains of the inverse functions. They have the same one, and then cosine uses a different quadrant. Sine and tangent both, for the inverse function, they use quadrant 1 and quadrant 4, and they don't use the other ones at all. When they use those functions, they only go from -π/2 around to +π/2. So what does that mean? Am I allowed to say 7 pi over 4, which is in the fourth quadrant? 7 pi over 4. No, I can't, because I have to use negative pi over 2 till positive pi over 2. So instead of 7 pi over 4, what do I actually say? Negative pi over 4. It's coming back to you. You remember doing this quickly last year. Cosine is the nicer one. Cosine's friendlier. It doesn't use 3 and 4. It uses 1 and 2, which is nice. That's why cosine uses 0 until regular pi. That one is the nice one. So if I use 5 pi over 6, it's still 5 pi over 6 using the inverse function. So what does the inverse do? The inverse says, if this is my value, give me the angle that gives that root 3 over 2. That's actually what it says. If this is the value on the unit circle, go backwards and get me the angle that would have given that value. Problem is, you're not allowed to use all the quadrants. You can only use 1 and 2 for this guy. So if it's positive root 3 over 2, what quadrant are we in? The first quadrant. So that's our positive cosine quadrant. Nice and easy then. What's the answer to the question? The angle in that quadrant would be pi over 6. Easy. Okay. Not 3, 6. I wanted you to see why that's important. This question is different. This question doesn't use an inverse. This question doesn't have a domain restriction. This question asks the same thing. Give me the angle that gives me this root 3 over 2 value, but because that symbol inverse doesn't show up, you use quadrants 1 and 4 in normal order. So if I asked you for this, then x would be, what's the first quadrant angle? We got our pi over 6. What's the other quadrant angle in quadrant 4? It's 11 pi over 6. And because there's no restriction, you got to repeat those answers every single time, over and over and over and over. Plus 2, how do you guys write it? 2k pi? 2 pi k? 2k pi? That looks so funny to me. Let's do plus, no, I don't like it written that way. Plus 2 pi times k plus 2 pi times k, where k has to be an integer. I'm going to write it friendlier. In the other class, I wrote it in math notation. No one had any idea what was going on. What does that mean? It means this is one of my answers, but I could go around 360 degrees, and that would be another answer, and I could go around another 360 degrees, and that's another answer. The second column has an infinite amount of answers. It also gives you 2 quadrants to work with, but this one here only uses the first and second quadrant, therefore there's only one answer. 1 versus infinite. What's the difference? This one said use the inverse, and this one did not say to use the inverse. Okay? Questions are the same. Let's look at negative root 3. Tangent inverse uses first quadrant and fourth. If it's negative, what quadrant am I in? Fourth. This one's a little bit harder. Tangent is root 3, so that would be root 3 over 2 over 1/2. Sine over cosine. Therefore, it's a pi over 3. I'm kind of giving you how I go through tangent problems. If it's root 3, I know the root 3 is on top, the 1/2 on bottom. This is my sine. This is my cosine. Therefore, I know it's pi over 3. But if I'm in this quadrant, normally it'd be 5 pi over 3. What do I actually write? Negative pi over 3. Good. And then over here, now that I'm not using the inverse, the only difference, I have to give you the second and fourth quadrant angle. I have to give you both. So what is the answer for this guy? It's going to look very similar to the cosine problem. I would give you x equals, and this one's actually a little bit different. I'm going to give you this angle here, which pi over 3 is in the second. 2 pi over 3. And what's nice, the other angle is here. How many degrees did I go around? 180. That's the same thing as pi. How many degrees did I get around to get back to it? 180 degrees or pi. So this one, you would plus k pi, where k is an integer. A little different. You don't have to write it twice. You have to write this one twice because they're not set up where this side around and this side around versus this side around. They're different, so you have to use two statements. All right. Now that I have that, these questions always confuse people. I see you guys do it all the time. Sine of 0. What is this in here? Angle or a value? Sine of 0. It's actually the angle. Where is 0 as an angle? The right side. What is the sine value of 0? 0. This one's different. What am I giving you? I'm giving you the value. Giving you the value. The answer is still the same, but I need you to understand why the questions themselves are different. So the value is here. The angle that gives you a value in the inverse would still be 0, but I needed you to see that the questions are actually different. Okay? I usually see cosine of 1. Most people give an answer for that. They'll say the cosine of 1 is 0. It's actually the cosine of 0 is 1. We get those confused. That's why I wanted to make that point. So, I'm going to have to skip through. I'm not going to do the proof today. I do want to do this proof because it is interesting. I'm going to give you the derivative rules today. You're going to use your derivative rules today. You will use the other time to study for the quiz that's tomorrow. You must know your 6 trig inverse rules on top of all the other ones. For every time you learn new ones, figure out a way to memorize them. These are actually, they look complicated, but they're a little easier. Start out with the first one. It's 1 over the square root of 1 minus x squared. Start with that one. Cosine. Start with a negative 1 on top. Over 1 minus x squared. They look exactly the same. What's the only difference? The minus. That's going to happen every single time now. So tangent, 1 over 1 plus x squared. So what's cotangent going to be? Negative 1 over 1 plus x squared. This is the same thing as x squared plus 1. For some weird reason, books always write it this way. Secant, secant's a pain. Secant's the ugly one. 1 over, yes, you heard me right, square, not square, absolute value of x, square root, x squared minus 1. And where's the confusion? This one says x squared minus 1. This one says 1 minus x squared. Can you flip them with a minus? No, you can't. So they are different. And then this guy, just put a negative. So really, you're memorizing 3 of them. You're only memorizing 3 of them. Down here, I want to show you how the book labels them and how other textbooks label them. They label them a little different. Because if this is a chain rule, if this is the inside, then this would be the open parentheses. So I'm going to show you the way the book writes them. 1 over the square root of parentheses u squared times du dx. And I'm going to highlight for you so that you can see where this is coming from. Here's the derivative of the outside. 1 over the square root of 1 minus just plain parentheses squared. That's the derivative of the outside. What is the inside function? That u. Remember we put the inside back? That's the inside. So what's that du dx in the back? Derivative of the inside. Do you see that there's 3 pieces there of the chain rule? This rule and this rule up here, they're not different. They're not different at all. Okay? Tangent, so if I wrote it with the u's, it would be 1 plus parentheses u squared times du dx. There's the inside. And then the very last one would be absolute value of u, square root of u again, squared minus 1. This is usually the one people get confused about. This u and this u, you'd write it twice. So if it said secant inverse of x squared, then I would have an x squared here. I'd have an x squared here. And then, let me move this out of the way, times the du dx, which would be the 2x. So the rules, sometimes I notice people get really confused when they see them this way. They're telling you, I'm putting the chain in for you. Okay? Without chain, with chain. It's the only difference. So if you're still using empty parentheses, these are your empty parentheses. This x here, this x here. If you're still using that method, I wanted you to see what your empty parentheses would be. Some of you need to use that. You don't understand how to deal with that. Empty parentheses first, put your inside back in, then you can put the multiply by the derivative of the inside. Those are the rules. If you want to see one of them get done, we can try one together as the bell rings. So let's do one with a chain in it. Let's do secant. All right? How many of you guys remember the rule already? Thumbs up if you do. 1 over absolute value of u, square root of u squared minus 1 times du dx would be the one with the chain rule. I'm going to do it without. Always label your work. The outside is secant inverse. Okay? So secant inverse's derivative, the outside's derivative, would be 1 over absolute value empty, you can put parentheses if you like, square root empty parentheses squared minus 1. That's the pink derivative of the outside. What do I put on the inside? X squared. 1 goes here. 1 goes here. And then multiply by the 2x. Most of you guys always get that part right. Multiply by the 2x. So my answer would be 2x over absolute value of x squared. It's actually pretty interesting how this works out. We'll talk about it later. Square root of x to the 4th minus 1. The absolute value of x squared, I do want to mention it. You actually don't need the squared let me see. It's the easiest way to say it. You don't need the absolute value anymore because it's always positive. Does that make sense? Oopsie. You don't need the absolute value because when you square a number, what always happens to the number? It's positive, so the absolute value is doing nothing extra. All right. Homework is finished 20. It's just using your rules. Study for your quiz, please. And memorize these rules because you got 5 more coming tomorrow. You got to memorize them in pieces or you're going to get stuck and overloaded. Memorize them in pieces.